Great. So in our day 2, what we were to cover was introduction to Rust, and that is where we're going to begin. Just some heads up, you guys you're going to be required to ideate on your project. So the demo project, like I said before, for you to be certified, you're going to be required to submit a demo project, which is going to be reviewed. And if you pass, then you get your certificate. If you fail, then you won't be able to get your certificate. So there are really no theoretical exams at this point. It is something you're going to think of and implement a smart contract based on your idea. So that way you're going to be able to get certified. So start ideating on your project ideas again and work on them as soon as you can. Now, what you're going to need for this particular session is going to be Rust, of course, installed in your machine. And while doing that, you're going to have Cargo and other libraries like Rust C, Rust App installed within your machine. So those are the main tools you're going to need for this particular session. And what you're going to cover basically today is going to be variables. So you're going to talk about how to declare variables in Rust, data types, and control structure. So in this case, the if statement, the match statement, or the loop statement. And yes, let's get our hands dirty now. So I have my file already there, and my source, when we're going to write our code, you realize it's arranged in 3 days, so 3 directories. So these are modules in Rust, okay? Again, we'll be learning more on this as we proceed. So in our day 1, you realize we're going to talk about variables, types, conditionals, and loops. So these are the control structures I was talking about. But even before we get there, okay, I want us to see how we can do a very simple Rust program before you even start using this particular architecture. So I'll just, okay, let me just open up this in my, have this opened up in my terminal. Then I'll just share this terminal again with us. Great. So we are here. Then I'll just increase the font. Now, guys, this is going to be very interesting. Now, once you have Rust installed in your machine, how do you know that you actually have Rust installed within your machine? So you run this particular command, Rust app. I don't know if that is quite visible from your end. Yes, I hope that is now visible. So Rust app -- version. Great. So this gives me Rust app version 1.2.5. Then I said, while installing Rust, there are other libraries or packages that are going to be installed automatically. One of these is Rust C. So Rust C is basically the compiler we're going to use to compile down our source code into a binary file that is executable. Okay. So Rust C -- version is giving me Rust version 1.6.1. So again, I have that within my machine. Then the other thing that I said is going to be installed is Cargo. So again, let's check the version of Cargo. So I have Cargo version 1.62.1. Great. Now, with that simple command, I've been able to establish that Rust is actually installed within my machine. Now, let's go ahead and create a simple Rust program. So in this case, a Hello World Rust program. So I'll just create a file. Now I'm working from a directory. Again, I'll open this in my editor page, so don't really be confused. I'll just call this file hello.rs, and I have that already created. So I'll just launch it in my VS Code. Great. So you realize that right here, I have this file and I've called it hello. Oh, I think you guys are unable to see this. Let me just share this. Okay, so here we are. I just opened the file we created from our terminal in VS Code. So it's apparently empty. I've not added anything to it. So right here, we're going to do a function, a very simple function that is basically going to print hello world in our terminal. Definitely the usual entry program to any programming language, okay? Now, something to note with Rust is that for your program to be executed, it must have an entry function. An entry function is where the compiler is going to start executing your program. And it is going to expect the name of that function to be explicitly main, okay? Nothing else. So this is how we do that. So my compiler is going to expect the function I've just written there to be available within my program before it can proceed compiling it down or executing it. Now that I have that function in place, I'll just print to my terminal this string. And again, don't worry about how this is all coming into play. We're going to go through all these. We're going to see how everything is working. So I have this in my hello.rs file, and there's only one statement within that function. So the function is main, and inside that function, there's only one statement, that is print line hello world, okay? So that is what you will, this is basically the string we're going to print to our terminal. Now, for me to be able to compile this down to a bytecode or something that is actually executable by my machine, because these are source code, I'm going to use Rust's compiler, that is Rust C. So I'll do Rust C, then provide the path to my file, in this case, hello.rs, and I'll just press enter. So that is going to basically compile down my source code into a bytecode called hello. Now, if you're on Windows, you realize that that has just happened, and I have hello file without any extension right here. If you're on Windows, this is going to be hello.exe. So basically an executable file, an executable hello file, right? So if you double click on that file, your program should be able to run, okay? But I'm working from Linux, I'm working from Ubuntu. That's why it has given me something different. But then I still should be able to execute this bytecode from my machine. So how do we do that? I'll simply provide a path to that file from my terminal for me to be able to execute that. So I'll just do hello. And since the bytecode has no extension, I'll not give it any extension either from my terminal. So I'll just do hello, and you realize it prints hello world from my terminal, okay? So that is basically how as simple, you can do a simple and quick Rust program, basically compile it down and be able to execute it from your terminal. Now, that aside, I'm going to head back to the project, to my terminal, and talk about cargo. So here we are. I just clear this out for now, great. Now, the other package I said that is going to come installed by default while you install Rust is cargo. Now, cargo is basically going to help us bundle our project into some sort of project architecture or folder system. Makes it easy for us to work within our project, test our program, build it and run it and all that. So it's really coming in handy. If you're coming from a JavaScript background, then look at these as NPM. So you're installing Node.js within your machine, but then at the background, it is installing a package manager called NPM. So you can basically create a new project using NPM in it. And you can as well pull packages from NPM using NPM install, right? So all that is made available by the help of NPM. So in Rust, we have the same thing, it's only that the name is different. And at this point, we are calling it cargo. So using cargo, we can be able to add other libraries into a project, make use of libraries that some other people have worked on, be able to initialize our project, so in this case, create projects, and be able to maintain a project. So something like that. That is basically what I'm going to take us through now. So if I run cargo in my terminal, you realize that it's giving me a bunch of commands right here that we can actually run from our terminal based on what we want to do, of course. So right here, there's a new. So you can do cargo new. This one is going to create a new cargo package. So basically the project you're going to work from, okay? So that's exactly what I'm going to use. So cargo new is equivalent to npm init. For those of us who are coming from JavaScript background, I'll be giving us some similarities where possible between this language and JavaScript. Basically how we do things here and how it is done in JavaScript, just to give you that relationship that is existing. So I'm going to create a new project. So I'm going to do cargo new. Then I'll give the project name. So let's give this project name MBS for Mombasa. And yeah, just hit on enter. So it went ahead and created for us that particular project. So it went ahead and set up a project. So if I list some of the files I have here, you realize we have our hello.rs and the hello file we just created before. Then this intro folder that I opened earlier. Then our folder, so in this case, our project folder, MBS. So I'll just cd into MBS. That is the folder we just created. And I'm going to open this up in my VS Code. So I went ahead, we ran cargo new, and here is what was created for us. So we have cargo.toml file. Git ignore. I really hope you guys know what this file is for. Then our source folder, so SRC folder. So this is where all our source code is going to live in, okay? Now, if you're keen on my VS Code, you realize that there are some files that were just added out of nowhere, okay? So we had target coming in and we had cargo.log coming in. So what are these? Now, I'll just walk us through the file system just for a bit before we hop into what we are actually to cover today. Now, if you're coming from JavaScript again, after doing npm init, if you open up that project, you're going to realize that you have some project. There's a folder system already in place for you. So usually you have package.json in place, you have node modules folder somewhere, you have your index.js somewhere, and that is just to give you some basic arrangement of how you should sort of arrange your file or your project should look. Now, the package.json file in an npm project or the Node.js project is what we have here as cargo.toml file, okay? So in our cargo.toml file, this is where we're going to have all our project configurations go. So you realize if we have any dependent package, or we have any package we are pulling from crates, in this, if you're in JavaScript, you would pull it from npm, right? So at this point, we are pulling it from crates.io. Again, I'll talk about that as we proceed. So all that will be listed right here, all the external libraries we've used. So right here, we have the name of our project, the version of our project, and the edition of our project. So all that is listed here. So cargo.toml is basically a configuration file within our project, okay? Then cargo.lock is basically locking all these information and, having it solid for our project so that we can be able to basically carry or move our project from one location to the other and be able to, pull all its dependencies and set it up quite quick. Now, this target folder or directory that was added out of nowhere, this is where we're going to have, now after building our project, while we generate the bytecode or the executable file for our program, it is going to be stored inside this folder. So inside the target folder, just somewhere. I'm going to show you again where that is going to be put. So that is basically its use. It has some other things that we may not cover in this session. Then to our favorite folder, or the folder we're going to interact with for the better part of the sessions now and to come, is this source folder or the SRC folder. So this is where all our source code again is going to live. And at this point, you realize that we have the same function we wrote in our hello.rs program that we've just written earlier. So we have a main file. Our main file is the function where it's like our entry function to this particular program of ours. So this is where the compiler is going, the function the compiler is going to expect to find and start its execution from. So within our function, we only have a print statement, and it is basically displaying hello world. Now, how do we run this file or this program of ours in Cargo? So again, usually in Node projects, you do npm run, something like that, or Node, then you pass the file you want to execute and all that. Now, in Rust, instead of going through the process we went through previously without Cargo, you remember we first of all compiled it down to a bytecode. Then from there we executed for us to be able to actually see the string or the whatever the program is outputting. Now, Cargo makes this easier by just doing all that in one line of command. So if you do Cargo run, this is going to first of all compile it down and execute the bytecode generated. So you realize that it is displaying hello world out of the box. So what happened behind the scene? First of all, it compiled it down to a bytecode, and I'm just going to show us that. Again, I said it is going to be available somewhere within our target. So if you follow target inside our debug folder, we have MBS bytecode. So here is where the bytecode was stored after being compiled down, after our source code was compiled down. It was available here. Then after it was generated, it went ahead and did what? Executed it on our behalf. And that's why we were able to see the hello world right here. So that is basically it, how you run a program within your Rust project, guys. Okay, I really hope that is home, or that's clear up to that point, because I'm just going to now share the workspace we began with. So this is what I opened up earlier. Great. So like I said, we're going to begin with, or we're going to cover the following today: variables, types, conditionals, and loops. Okay. So we're going to walk through these. I already have the file kind of set up in a way that is going to help us move quite quickly. Now, just allow me cover, before we even start, we proceed with variables, just allow me to say something. So you realize I'm having my main.rs file. So this is where, this is the entry file to our program, the main.rs file. And it has a main function, again, the entry function to our program. So this is where all the executions are going to start from. Now, within my main folder, I'm bringing in a module. And this module is named day one. So day one is basically this folder right here. So we are bringing, it's a module. So in Rust, it's a module, okay? And we are bringing it in. And this particular folder is a module, and that is sort of depicted by the file mod.rs. So again, it's a convention. So mod.rs is not just any function you can, any name you can think of and put within your within your module. So it's like the entry file to your module. Okay, that's why we have it named mod.rs. Now within your module, within the folder day one, you can now have you can name any file within there. You can give it any name you want, as long as you follow the naming conventions that, again, we're going to talk about. So yeah, all that must be covered. So these are module, and within my module, again, I have a file. So there's a file _1_ variables right here. So these again are just where we're going to put our source code. So I'm importing it to our mod.rs using mod keyword, and I'm passing in the name of that file. Then within that file, within these file variables, there's a function called run. Now you can give any name to this function. I just so it better that we go with the name run. So you basically pull it in, okay, into your mod.rs file, and we are running it as captured in line 7. So you're basically doing this module. Then we use 2 colon, so 2 full colons. Then we follow it by the function name that we want to run. So that is basically how we're going to, that is basically how this particular project has been set up. Okay. Now, again, I'll be talking about functions and all these importations as we proceed. So don't be worried about that for now. So the very first thing I want us to, and again, I'll be sharing this file in a GitHub repository, guys. Okay. So don't really get worried about, you know, being able to do this or that as we proceed. I'll be sharing a link with us. Great. So here we are. What is a variable? Maybe you can start from that. Yes, Brian?
Variable is a container that stores data, the same value.
Yes. So a variable is a named storage space in your computer memory. So congratulations, guys, for trying. So a variable is basically a named. So the very first thing you have to notice the name. So a variable is a named memory location within your primary memory or within the primary memory of your computer. So that is the RAM. Okay. So you're going to have some space that is going to be allocated to the variables within your program, but then these spaces are going to have some references to them. Or there's a way we can be able to sort of know them or call them. Okay. So it's not just random. Okay. So they are named memories. So that's a good trial. So there's a note right here. Again, I'll be sharing this file, guys, so you'll be able to read more. Variables hold primitive data. Now, this is in Rust. They hold primitive data or references to data, and they are immutable by default. Now, in Rust, variables are immutable. By immutable, I mean once you declare it, it cannot be changed by default. Okay. So again, we are saying by default, it means there's something you can do for you to be able to go around that, for you to be able to change the value within that particular memory space. So by default, it is mutable, and Rust is a block scoped language. This means if you're going to define a variable, say, in a different block, and you expect to use it in outside that particular block, then that may not really be possible. Why? Because Rust is block scoped. So we're going to have local variables, global variables, and, you know, all that. So again, we're going to talk about that as we proceed. So let's get these rolling. Now, the very first thing we're going to do is see how we can define a literal variable. Okay. So how can we define a variable in Rust? If you're coming from JavaScript, you're going to find this a breeze, I promise you. So usually in JavaScript, there's this keyword. Sorry, if you're coming from the is it ES6 or what? Yeah, there's this keyword available, the let keyword.
Yes, yes.
Yeah, that you can use to, you know, define your variables. So let's say we need to name the space, the memory we want to allocate for this value X. And we're going to assign the value 34. Then we terminate that statement using the semicolon. So take note of that. Okay. Usually in JavaScript, you can ignore and your program will just run, you know, smoothly. But in Rust, failure to do that, you're going to have some consequences. So yeah, this is how we do that. So we have a variable called X. This variable is storing a value 34. And in my VS Code, I have, because you're going to see this a lot as we proceed, so it's very good I clear the atmosphere before we proceed. I have an extension called Rust Analyzer. Yeah, so here it is. So this is the extension. So this is what is, this is the extension that is hinting this type. So you realize it's telling me that, hey, the value 34 is I32, is of type I32. So again, I'll be covering that in a bit, what types are. But for now, just ignore that, okay? Don't be worried about that for now. So if you're on VS Code, just go ahead and grab this extension, Rust Analyzer, and it's going to make life easy for you. So this is the basic way you can define any variable in Rust. So you can you can simply do that statement for integers. If you wanted a string, then you can basically do, let's say this is a word, and it could be hello, right? Very simple. Then we terminate that. So we have x, variable x and variable what? So variable x has value 34, so that's an integer. Variable word has value hello. And my Rust analyzer is hinting this particular data type, ampersand str. Again, we'll be seeing what those are as we proceed. But for now, just take it as it is. That is basically how we define variables. So let's print something on our terminal. We're going to use this particular macro. And I'm very sorry, guys, I'm using a lot of jargons with this, but I'll be putting everything into detail as we proceed. So for now, just know that for us to be able to print anything in our terminal, we need to use that particular statement in line 13. Okay. Now I'm going to print X. So again, that is how I do it. That is how I basically print it. And for me to be able to run this file, if you can remember, I only need to do cargo run. And that should be able to give me 34. Now I still have hello world somewhere. I think it's coming from my main file. So I'll just get that out because we're not talking about that now. Then I'll just do this again. So you realize I have 34 right here printed in my terminal. So that is variable X. We just printed its value. What if you wanted to print the value for variable word? So I'll simply replace that X with word. Then I'll do cargo run once again. And you realize that this time round, it gives me the word hello in my terminal. So that is basically how we go about that, guys. That is basically how we go about that. Now, the other thing very fast. So we need to define a constant variable. So what is a constant variable? A constant variable is basically a variable that we don't intend its value to change any time within the lifetime of our program. So once we've given it a value, we don't expect its value to change at any given point in time within our program. So that is why we have the word constant. So the value is constant. The value is not changing at any time within the execution of our program. It will remain the same, okay? So that is what we basically refer to as a constant variable. And how we do or how we implement that is by using the keyword const. Again, if you're coming from JavaScript, these should be familiar to you. So we have const, then I'll call this const pi. So that is the variable name, pi. Then I'm just going to give this some value, 3.142. Yeah, so this one is telling me to give it some type. So I'll just give it F64. Again, I'll be talking about types, guys, in a bit. So this should be lower F, great. So I'll be talking about types in a bit. So for now, the expression in line 16 is basically illustrating how to declare a constant variable. So in this case, we have the const keyword used. The variable name is pi, and if you can be very keen, it's the variable name is sort of taking the uppercase the uppercase characters. Then we've given it a type, which again I'll be talking about in a bit. Then it has a value. Now, we don't expect this value 3.142 to change at any time within the execution of this program. So we expect it to be that way. So even if you try changing this, the compiler will refuse or will raise some errors if we try to. So maybe I can just show us this even before we proceed. So I can try allocate some value right here, 67. So you realize there's an error being raised. Okay. Let me just have this, put it mutable. Now, if I said that variables are immutable by default in Rust. So if you wanted to make them mutable, then you need to use this keyword mute. Okay. You guys will see how we make use of it, but that is basically what we do. So if I hover over that, you realize it's telling me that a mutable variable reference or pointer. So let me just get the error. Oh, so we have it right here. So mutable row pointer work much like mutable references. Right here, const globals cannot be mutable. In other words, a constant variable cannot be mutable. So that is basically what the error is trying to tell us. So that means I really can't be able to change its value. So again, that is how we go about it. So I'll just try and print this value. Let's now print the value pi to our terminal and see what we're going to get. So I'll just run cargo run. Let's just do cargo run. And down here, it is printing to us 3.142. Again, that value. Okay. Let me just exit that for now and let's proceed. So we also can be able to define multiple variables at a go. So in one statement, you can be able to basically define multiple variables and assign values to them. So how do we go about that? We do let, then this is going to be a tuple. I know if you're coming from JavaScript, this may not really make some good sense to you, but if you're coming from Python, you should relate something right here. So we're going to, we have a tuple at this point, and we're going to have, in our tuple, we're going to have a name and an age, okay? So we have something down here. Then I'm going to assign some values to these guys. And I'm going to say that let the name take the value Paul and the age take the value, let's give this 34, right? Awesome. So you realize at this point, we have this name. Again, don't worry about my compiler suggestions. I'll be talking about types in a bit, but it's basically hinting to us that, hey, you can give some types to these guys. But we're not going to do that for now. So I have two variables declared at a go, however, in one line, okay? I have the variable name, which is taking the value Paul, and a variable age taking the value 34. So if I try to print this in my terminal, let's see what it is going to give us. So we're going to have name right here. So name is age, years old. So that that comes down to string formatting. We'll be talking about these things in a bit as we proceed. So let's see what this is going to give us. So we do cargo run, and you realize it is printing out Paul is 34 years old. So it basically went ahead and right here, basically went ahead and took this value, put it inside this variable, took this value and put it inside this variable, and then formatted as string and displayed the final output. So that is basically what happened. behind the scenes. So let me just have that cut. Sorry, just have it in for now. Then exit this for a while. Great. So that is basically it about variables, guys. For now, let's talk about comments. So what is a comment in a program? And again, I'm going to ambush someone right here. Gabriel Egesa.
Yes.
Yes, Gabriel. Thank you for unmuting.
Okay. Comments are additional information.
Yes.
Which try to describe what is being done, but they're not run. Use.
Yeah, sure. So yeah. That's very excellent. So comments are basically additional explanation of our source code or our program code. Okay. So we are trying to do some statements like I've been doing before with the variables. So you realize I'm having some statements coming right here. So define literal variables. So this is how we do it. Define constant variables. And this is how we do it. So they're basically giving some more explanation about the code. Okay. And these statements, so the comments that we have within our program are not going to be compiled down. They are not going to be carried over to our bytecode. So our bytecode is only going to contain the actual program statements, okay? Or the instructions we've given the computer. So in this case, these are what are going to be carried, but then these, the ones in green are not going to be, they are not going to have any place within our bytecode. Those ones will be left within our source code, but they are there to, for elaboration to coders or developers like you guys, just give you more explanation of what is going on within the program. Now, we have two types of comments within Rust programming language. The two are used to give more information about the code, but we still have another level of commenting in Rust that is majorly focused for documentation. So if you're planning to do a library in Rust, but then there's a way you wanted to sort of provide some documentation about your library and be able to put it outside there for people to easily adopt it within their solutions, then there are some types of comments that you can use. So apparently we have documentation comment, the very first type in this case, the documentation comment, and documentation comments appear like that. So from line 1 to line 7, that is a documentation comment. Basically, it comes inside a slash, then 2 asterisks, then you can write anything inside there. Okay, so your comment can go, you can do anything. So it contains a block of comment or a block of statement that is basically describing, it could be describing a function, it could be describing a module, it could be describing a structure. So all that, okay? But you are not advised to use it within your function body, okay? So if you're trying to do this, but then you decide to do it somewhere within your program, like inside here, you realize that my Rust analyzer is complaining and it is saying or telling me that it found a documentation comment that doesn't document anything within your, or where you've put it, okay? Docs comments must come before what they document. Maybe a comment was intended for this, so it is recommending the double slashes. So these are what we refer to as inline comments. So that brings me back to my second, sorry, what did I do? Yeah, that brings me back to my second type of comments in Rust. So the very first comment that you can use is documentation comment, which I've just shown us. It's block, sort of block comment. Then we have the inline comment. So the inline comment is what I've been using within my within the body of my function, the run function, and it is started off by double slashes. So you realize that the other one we used a slash, then two asterisks, then it ended with an asterisk, then a slash. So that is how it began. That is how it ended. But for inline comments, it is basically starting with double slashes or two slashes before you can write anything afterwards. So anything that comes within that same line is going to appear as a comment. If you intend to move to the second line with your comment, then you'll have to start it off again with the double slashes, then proceed with your comment from there. Okay, something like that. So that is basically how we go about commenting in Rust. I just thought it's good to mention that as we proceed. So that way you're able to know how things are now taking shape within our program. Now, yeah, that is it about the comments. So I'll just move on to display or displaying some things within our program. So let's say we want to display like the statement I've been using right here, print line, right? What is it exactly doing, or why? How can we use it within our program? That is basically what you're going to cover right here. And displaying values. So at this point, you're going to learn how to display values in console, not in an interface, okay? Not using any interface, in this case, any GUI. No, we're going to learn how to display all these within our console, within our terminal, within your command line if you're in Windows, okay? Now, the basic print line statement that you can use in your program to display any value is this. Print ln, then exclamation mark, then you finish it up as a function. Then inside it, you basically pass a string. And inside this string, we're going to have these curly brackets or curly braces, one opening and the other one closing. So that is going to act as a placeholder. It is going to expect some, let me call it parameters. So it's basically going to take a parameter and replace that, those curly brackets with the parameter we're going to pass that right there. So let's say we can have that. Then we can give any value within our string. So let's say value, colon, then we expect some value to be replaced, to be put in place of the curly brackets. So what is this value that you're going to put in place of that curly bracket? Let me just comment this out for now, so that we focus on this. Now, the value that we want put in place of those curly bracket is going to be 35. Let's go with 35 for now. Now, while printing these in our terminal, we're going to have value just as it is, the word value as it is, and the colon. But then these curly brackets are going to be changed or replaced by the value 35. Okay, I hope that is home. So if we try to execute this program, we expect this to print value 35 in our program. Exactly. So if you can see what I've just highlighted in my terminal, you realize it has printed out value 35. So if we wanted to change this to something else, say 50, can just make the change right there. Then do cargo run again, and this will now print value 50. So basically, this is being replaced by the value we are passing over here. So that is one way you can display information in your terminal in a Rust program. If you're coming from Java, this is the system dot usually a long statement. I don't know if I can remember. System.out.print something. Those who are Java developers around. Those who are Python developers, I think, Python makes it easy. Print, then you just give your value and you're good to go. Then JavaScript developers, this is what we have as console.log in JavaScript. Okay. So again, that is just for you to be able to relate things. Now, we have the second format coming as basic basic formatting. So again, this is just going to give us how we can basically format our string. Now, the first one I gave, this one, falls under this point. So this is how you can basically format the string that you want to display. But if you just wanted to print out something in your terminal, then you realize that the values that are going to be replaced for these curly brackets are coming after a comma and after this string. So after this string, there's a comma, then the list of values that you now want to do what? To display or format within your string. So if you just wanted to display the string, so you have a string in your mind, like the one we used to have, hello world. So hello world doesn't require you to pass any argument to it. So you just pass it in as a string. So that is how you do that, how you would basically do that. But now when you come to string formatting, it means you have a string, but then you have some places within your string that you need to customize. So instead of just printing it as it is, you need to get some value within your program and sort of put it inside your string for it to be formatted quite well. Just like what we did with the value. So we are having a string, but then our string is requiring some value right here. And this value is basically coming from our program. So we are passing it in as a parameter right here. So that is how we basically go about that. Now, the second one is what we refer to as positional arguments. Okay. Let's see what positional arguments actually look like. So it is still going to use the println macro, and we're going to have a string that we're going to format using our values. So again, at this point, I'm going to use a name. This time around, I'm not going to use my name, so I'm going to use a name. So this name comes from a town. So again, we don't know this town up front, so we're going to expect to pass it as a parameter. So this name comes from town, and they like some color. Okay, so this is basically the sentence you're trying to sort of build up. Now, like I said, for us to be able to pass the parameters, we have to bring in the values after this comma. Okay, so the comma basically separates the string you're trying to format and the values. So right after the comma, we need to provide the first name or the name that we want to put right there. So let me use Brian. So let me give Brian that credit. So Brian comes from, Brian, where do you come from? Hey, Brian. So let's now just use Mombasa for now. So Brian comes from Mombasa. And Brian, what color do you like? Okay, let me give you blue. Then I'll just terminate that statement. Now, if you keenly look at this statement, let me just make this a bit bigger. Great. Now, we want to display the name Brian right here. So as it is, it would basically work. Okay, it would basically work as it is. But then with positional argument, it means we are giving some numbers indicating where the program or where these print statement should retrieve their values from. So like in our case, the first placeholder would say, hey, pick up your value. So take the first value in the list of values. So from this list, okay? Pick the first value. So the value, the pick value 1. Then the second placeholder is going to pick value 2. And the third placeholder is going to pick value 3. So it is positional.
Hello, sir.
Yes, hello?
This does not work with index. I said this does not work with index.
Yeah.
Index from 0, 1, 2, 3, 4, like, because and index is this one should be 0.
Yeah.
And the other should be 1. And the other should be...
Yeah, sure. This is 0. Yeah, thank you, Destiny, for that. I think I was getting ahead of myself right there. Great. So we are having 3 elements. So these 3 elements or these 3 parameters are going to be in sort of like an array representation. So the first element is going to be at index 0, which is the position we are giving right here. The second element is going to be at index 1, which is what you're giving over here. And the third element is going to be at index 2, which is actually what we are giving here. So if I try to print this out, let me just bring up my terminal. Great. So if I print this out, what's happening? Okay. So let me do cargo run. So you realize it is printing. Focus on the statement I've just highlighted. So the last statement, Brian comes from Mombasa and likes blue color. So it basically went ahead and did what? It replaced the values we have right here for that statement. So again, using the positions. So in this case, the index of our values.
Okay, can you screw up? Let me see how you run it, because I was saying something different just now. Just screw up to the place you run the code.
So I have cargo run.
Okay, I thought maybe it was a typical error. I saw you. Maybe I thought I saw cargo run.
No, it was cargo run. The command is up here. This one. Are you able to see that, Destiny?
Yeah.
Great.
Yeah, I remember.
Awesome. So that is basically what I did, and it went ahead and executed our program, and that is basically what was displayed. Now, the other way, so we are still displaying things on terminal, but we're going to look at another way that we can basically go about that. Now, the other way is called named argument. So we can basically name our argument instead of these giving, the indexes and all that. We can actually give them some names. So I'll just go ahead and do that right now. Let me just exit my terminal for now so that we have a good view right here. Now, again, after the comma, so after the string we are formatting, I'm going to give the value Brian a parameter name, and I'm going to call this parameter name. So I'm just going to have it as name. So name is going to be equal to Brian. Then Mombasa is going to be a city. So yeah, so the variable city is going to contain the value Mombasa. Then I'm going to have the third variable right here called color, and the color is going to hold the value blue. Now, what if I decided to interchange these parameters so that instead of having city at the middle or coming second in my list of arguments, I have it come last at that point, okay? I have it come last. Then I'm going to have name come second in the list, like that. So at this point, we have color, blue, name, Brian, city, Mombasa. So instead of using the indices or positional values, I'm going to actually provide the actual name, the actual variable name. So in this case, the color, the name, and the city. So I'm going to have name come from a city and likes a color, right? So these values are basically these variable names are basically going to be replaced by the values they contain. So the name is going to be replaced by Brian, the city is going to be replaced by Mombasa, and the color is going to be replaced by blue. And it doesn't care the order in which the values are arranged. That's why I decided to, just disarrange them or disorganize them than the way they are. So it should still print the same statement as what is being printed in line 40. So at this point, we should have some two similar statements being printed up. Let's see. Let's just see how that is going to be done. So right here, so focus on the last statement. It is similar to the same statement that is coming before it. So Brian comes from Mombasa and likes blue color. So we can do the same thing right here. Maybe you can just change the name. Let me change this to Destiny. Destiny comes from Nigeria. Okay. Destiny, what color do you like? Let me give you green.
I like blue. I like green, but I didn't understand this aspect. This place, I'm a bit confused. Like seriously, in this named argument.
Yeah. Let's repeat this again and see. So you have Destiny comes from Nigeria and likes green color. Now, Destiny, you're saying you don't get something with the arguments, the named arguments.
Yeah. The named argument. I'm trying to capture it because I saw you passing in name, passing in city, passing in color, and okay, assigning color to color, name to name, city to Nigeria. Okay. So you assign the color, which is the green to color, and passing color. Okay. Color breeze. So okay. I understand now. You can see explain for that photo.
Yeah, great. So we basically are sort of having some variables holding our values. Then you're basically passing in the variable name right here. It's sort of what we did somewhere up. Let me, I think we've not done it, we don't done it before. But it is, you could have a variable within your program, say, like the ones we have at the top. So we can have variable X. Then you want to print variable X. So we can simply come here and do X. Then that will basically replace the X variable with the actual value that variable is holding in our string. So that is basically what we mean by named arguments.
That's if the S or if the variable is assigned to S, or is it the S that's assigned to the variable? Like, let's say let S equals to I. Then when S is in that curly braces, it automatically prints out I. Am I correct?
Equal to I. So
yes,
something like that. So if I pass S right here, I expect this to print I comes from
yes.
But then you realize that there's some error within my statement. So at this point, I'll have to do away with these. Let me do away with this
name
statement for now. Yes, that should take away the error. Then, so if I try to execute this, let's just do this. So it's printing I comes from Nigerian likes green color. So it basically took, where is that value? It basically, sorry, right here. So it basically took the value I from the variable S and dropped within that placeholder. Okay, so that is basically how we go about that. Let me just undo that.
Thank you.
Great. The other thing I want to talk about is placeholder traits. Placeholder traits, think of them like you wanted to display an integer within your string, but then you wanted to format this integer before displaying it. Okay, again, let's see how we can do this. So let's say we have we need to print our normal statement. So right here, we're going to have, we're going to display an integer, okay? But then instead of just displaying this integer as it is, we wanted to format it into either a binary, a hexadecimal, or an octal within our string. So for us to, from one integer, be able to get different representation depending on the base or the numbering system we are using or we've specified within our string. So I'll have a binary representation of my integer. So the binary representation of my integer is going to be colon B. So that should help me format that. Then I'll just break this line, or for me to be able to, print it in the following line. So I'll see, I'll just need to use that literal \n. Then I want to print the hexadecimal representation of my, again, I can have a space here. Let me just have the space. So the hexadecimal representation of the integer I want to print, and that will be represented by colon X. Okay. Now, what other format can I print this? So I can print it in octal, right? So let's just put these as well right here. Octal. And I'm going to have that as colon O. Now, the integer I want to print as a binary is 10. So again, I'm going to pass this integer thrice because of the 3 placeholders we are having. So the first is here, the second is here, and the third is here. Okay. Now, these should print the integer 10, but in these 3 different representations or number systems. Now, let's run this and see what how this is going to run for display in our terminal. Yeah, focus on the last 3 lines of our output. Now, the integer 10 in binary representation looks like this. The integer 10 in hexadecimal representation is an A, so the character A. Then the integer representation of 10 in octal number system is 12. So you realize we wanted to print out the integer 10 in this case, but then we expected it to take different number systems. So I don't know if you're going to come across this within your smart contract development, but then if you ever do, that is that is how you go about it.
I pray we don't come back. I pray we don't come across.
Yeah. Yeah,
Yes.
I also doubt if you're really going to face this within your smart contract development, but if you ever do, just in case, that is how you go about it. Okay. Now, let's look at the last statement right here when it comes to displaying statements in our console. So this one says placeholder for debug traits. What does this mean? Up to this point, we've been talking about literal variables, literal statements. These are variables that they have their values stored in a stack or in a memory stack. So it's very easy for you to access these values, like the integers, the floats, the Boolean types. I don't know if you've talked about all that. We're going to talk about all that in types. We're going to have Boolean types and all that. So if you wanted to display all that, it is very easy to display them within these statements. Okay. But let's say you wanted to display something like an array. You wanted to display something like an object you've created from a class or a structure. It's not a normal string. So it's an object that needs some sort of formatting before it can be displayed. So how exactly can we be able to display such using this print line statement? This is how we do it. So we have print line. Then we have our placeholder as usual. But then within my placeholder, I'm going to use : ? for me to be able to display, let's say we had an array up at the top here. Let me just call this array. And I'm going to have this array. It's going to be a vector. Again, you're going to see what this is as we proceed, guys. So don't worry. Now, if I wanted to display this array, normally as we've been doing it before, so I've been having a placeholder, then I just pass in what? The variable name, right? So you realize that it is raising an error. And this error is saying that, hey, whatever you're trying to implement does not implement this trait called display. So it has no implementation on how it can be displayed in your terminal, okay? The vector in format string, you may be able to use this literal right here or this other one. So this literal is basically helping us display the object or the, let me call it the complex variable in our terminal, so that if it is an array, it is just going to come out as an array. If it is an object, it is going to come out as a JSON object in this case. So let me just use the colon, then question mark, and that error will disappear as it has done. Now, if I run this in my terminal using our favorite command, cargo run, so this one is going to display this object as it is an array, okay? So we have an array of 1, 2, 3, and 45 at that point. Now, that is basically how we would go about that. So again, I know we've covered quite a lot at this file, but that is it. That is all we wanted to cover. Now, let's talk about what is a data type. So this one basically defines technically it defines it gives some rules behind the value you're trying to store within a variable, okay? So it's kind of it brings in some bounds. So if you're saying you're going to store an integer, an 8-bit integer, then you give us an integer that has 16 bits. It means you violated some rules. And so your value is going to be invalid to be stored within the variable you just specified. And why do you have all these in place? Now, again, if we go down to memory management in any program and in any programming language, most of the typed languages, the likes of Java, C, C++, and now Rust, if let's say you said within your program that you want to store in a certain memory space, so in this case, the named memory space, the variable, you wanted to store a value, any value, as long as it is of type 8-bit integer, okay? So as long as the value is of 8-bit integer, it can easily be stored within that particular memory space. So if that means if you try to bring in an integer with say 16 bits, 32 bits or 64, or any bit beyond what you've specified, it won't fit within that memory, okay? And so if you didn't handle that well within your program, it means your program will crash or there will be an overflow. So it will be interpreted differently within your program, that value, okay? Let me just give us an analogy of what this means. Let's say you have a 10-liter jerry can. A 10-liter jerry can only hold 10 liters of water, okay? Then, let's say out of a sudden, you decide that, hey, you want to fit 20 liters of water within this 10-liter jerry can. Do you think that is going to be possible? It definitely won't, right? So if you try to, put all this together, then the jerry can would probably burst and it will cause some damages. So think of the data type, the jerry can analogy to the data type concept you're talking about. So if you're going to have a variable, in this case, the jerry can, and we specify that this variable can only contain this data type. So in this case, it can only contain these liters of liquid. Then you try to bring a liquid that is beyond what you specified, then there's going to be some error within your program. I really hope that is home. I've taken quite a while to explain that. Now in Rust, we have primitive data types. And the primitive data types in Rust, so we have integers, and integers can take all these data types. I've just highlighted them, okay? So all those data types, they all refer to an integer value. So we can have an integer value of 8 bits. We can have an integer value of 16 bits, of 32 bits, of 64 bits, and of 128 bits. Now, within the different bits, we could have signed integers, in this case, an integer that can be negative or positive, and we could have an unsigned integer, in this case, an integer that can only be positive at any given point, okay? So signed integers, in this case, integers that can be negative or positive, begin with the value I. So this I8 simply means it is an it is a 8-bit signed integer. That was sort of mouthful, but I8, again, if I repeat, means it is an 8-bit signed integer. A U8, on the other hand, is an 8-bit unsigned integer, and that extends to the rest of this. Okay, guys, I hope I never confused anyone. The same thing applies to floats. So floats are also literal data types. Sorry, primitive types. So we can have a 32-bit float value, and we can have a 64-bit float value. Now, floats are basically decimal values, okay? So we can have different bits for whatever, depending on the precision you've chosen for your program. Then we also have Boolean values, you have characters, you have tuples, and you have arrays. Now, again, let's see if we can cover all these within the short time we have. Great. Now, there's a note right here. Rust is a statically typed language, which means that it must know the types of all variables at compile time. However, the compiler can usually infer what type we want to use based on the value assigned and how we use it. Now, that is why you've been seeing in my other file, so in this case, the variable files, while I was declaring the variables, I was not explicitly giving the types. So based on how I've used these values, the compiler will automatically know what type it is going to assign to it. Okay. Again, that is why we say that all variable types must be known at compile time. However, the compiler can always infer what type we want to our variable based on how we use it. So that is basically why that was possible in my previous file. But within this file, I'm going to try to explicitly define them. Great. So let's proceed with integers. And in integers, now we have default data type for integers. Like for instance, the one I had in my previous file. And again, guys, let me change this. Now, at this point, I was running all the codes within my run function, which was within the variables file. So at this point, we're going to run block of statements from our types file. So that is basically what I'm going to uncomment right here. Sorry for that. That is what I'm basically uncommented. So we're going to run code from this types file. Okay. That is the only change I've made there, guys. I hope I didn't confuse anyone. So let's say we have let x be equal to 34. just the same statement we had previously. You realize that my analyzer is suggesting I32 data type. Why? Because it has inferred the value given, and the default data type for integers in Rust is I32. That's why that just came explicitly out of the box. However, if I wanted to give my variable an explicit data type, in this case, an explicit integer type, then let's say I had y, and I wanted a 32-bit unsigned integer. So I'd use u32 for 32-bit unsigned integer, then basically give it the same value, 34. So right here we have two different variables with different data types. Take note of that. That is basically how we do that. In float, the default data type for a float is F64 when you talk about float. Now, maybe just to recap something in integers, this is basically how you define an integer variable. So the U32 data type can be replaced with any of these data types we've seen up here. Again, depending on the precision you want to give your program, okay? So I hope that won't confuse us, guys. So down here, I'll just do, what can we do here? Let's do price. Then our price is going to be, now price usually have some decimal when you talk about money, definitely. So we have some cents over there. Now, even without doing anything, you realize that my Rust analyzer is suggesting the F64 data type. Why? Because it is the default data type for any decimal number or decimal integer within your program, if you've not explicitly done so, of course. So if you wanted to explicitly define some or give some data type to our value, then it would simply come down here. And let's do another variable, call it, let's call this cache. So our cache is going to take a 32-bit of float. So a 32-bit float value. And this one is going to, let's give it 100.00. I think that should work still. Yes. So at this point, we have the variable cache, but then it is of type F32. And that is the value. So we've explicitly defined that. Okay. Now, by adding an explicit type, I mean, instead of just leaving it as let price equal 100, you explicitly add that particular type. And by that, I mean what we've been doing before. So like what I just did over there, I can simply come here and say, hey, I want this to be an explicit data type. So it should be U128. Again, you can give any data type right here, depending on the value you want to use. Then I just come here and give some very huge number. So 128-bit integer really holds a very huge amount of digit or integer. So by explicitly defining this again, you explicitly provide the data type. So that is basically what we mean. How do we go about Boolean values in a Rust program? So this is how we do it. So let is what? Is true. Be equal to true. Okay. Yeah. So at this point we have a variable. Now let me just change this to that. Again, I'll be saying something small while we do that. So let is true variable contain the value true. So true is a Boolean value. We only have two Boolean values, I think, in any programming language in the world. So we can either have true or we can have false, right? Those are the two values you can have. So is true let's say is true takes the value true. And at this point, you realize it is suggesting a data type bool or Boolean data type. So we represent that data type using the keyword bool. Okay. That is basically how we do it. What if you wanted to get the Boolean value, but then you want to get it from an expression? So let's say if x is greater than y, store that, something like that. So at this point, instead of, assigning it or giving it value directly, we want to get this value based on some expression. So let's say 56 greater than 45. This one is actually going to be false. So let me call this bool val for Boolean value. So our Boolean value or bool val variable at this point is going to contain the value false. Why? Because from this expression, it's going to contain the value true. Because from this expression, the value 56 is actually greater than 45. Okay. So if we had these at the other way around, so 45 and 56, then it would contain the value false. Why? Because 45 is not greater than 56. It's actually less than. So this expression evaluates to a false value. Let me just print this out, or let's print something in the terminal for us to be able to establish this. You guys may think I'm just, giving out my, I think that is how we do it. I'm just running this in my head. So let me do cargo run. And that displays false at that point. Okay. So again, that is how we can get a Boolean or, create a Boolean variable from an expression. Then now characters. Now, when you talk about characters, we're talking of the single alphabetic letters we have in your alphabet. It could be an A to Z. It could be a 1 to 0. It could be any symbol, as long as it's a character, not a string, but a character. Let's see how we do this. So let's say we have a variable. Let's call this character. Okay. Then our character. Now, for you to be able to represent or declare or define a character variable, then let this stick into your head. You must use single quotation. Okay, so single quotes. Usually when you do a string, you use double quotes. But when it comes to character definition, you use single quotes. At this point, I'm just going to print character C. Okay, so let me just carry this print statement down here because I want to print this character value. So at this point, we're only going to print the character C. Now, if I tried to, add some characters right here, something like that, you realize it's giving me some error. And it is telling me that, hey, a character literal may only contain one code point. So just one character. And it is enclosed within the single quotes. And right here, the data type for a character is char. C-H-A-R. Char. Now, if I go ahead and print this in my terminal, you realize it's only printing out C as it is, the character value we have right there. Now, this could as well be these Unicode values. I don't know if you come across that, but we could as well use them to type, to print Unicode values. This could be emojis. Like for instance, let's use this. Let's print an emoji. So we're going to print an emoji in our terminal. Let's just name this to emoji. then give it. Now, these are Unicode character. Take note of the representation. It begins with a backslash, I think, then U, then we have an opening curly bracket, 1F600, then a closing curly bracket. Now, if I try to print this in my terminal, I'll be able to print, it should be able to display an emoji for us. So right here. So this is actually a laughing. This should be laughing emoji. Right? So we've, using this code, we've been able to display this in our terminal. And in our program, we represented it as a character. And that is what we were able to basically display out. Great. So that is it about characters. And now let's talk about tuples. Or is it tuples or tuples? Someone put it in the chat, or you can just unmute and let us know. So let's talk about tuples. So we're going to define, use the same expression we used initially. So we're going to have name, then we're going to have age, but this time around, we're going to give it what? A very explicit data type. So instead of just coming here and giving it some values, like say Fleming, I hope that is the right spelling, Fleming, please. I hope that is not your age as well. So at this point, instead of just leaving it as it is, we know it can infer default values. We want to give it some explicit data type, okay? So for us to do that, we just begin that using the full colon as usual, but then we enclose all these in a tuple, and within our tuple, we give the data types for the individual elements within our tuple. So this is going to be a string literal. And the other one, now you don't expect someone's age to be a signed integer. You don't expect someone's age to be a negative value at any point in time, right? So again, that makes sense. So at this point, you're going to use U. Let's use U32. So 32-bit unsigned integer, or unsigned integer of 32 bits. So at that point, we've given explicit data type to our tuple variable, or the variables we just defined right here. Now, something to note with tuples is that once you've declared it, none of its individual values can be muted or can change. Okay, so tuples values are immutable. They cannot be changed once declared, once defined. So you can't expect us to come here and say name is equal to something else, you know. That is going to raise an error. Cannot assign twice to mutable value. That, let's say we could make these mutable. So the moment I add the word mute, it is giving me some error down here, and it is telling me so this will basically raise an error. This will basically raise this error. So we basically can't achieve that out of the box, but I guess there's a way we can go about it, go around that definitely. Okay, so that is basically how we give explicit data types to our tuples. So down here, again, if I wanted to display this, now you realize I'm only using one print statement so that again, we don't, have some ugly representation within our terminal. So at this point, I may want to display name and an age, right? That is basically how I would print them out in my terminal. So that is what I'm going to do. So if I do cargo run, you realize that I have Fleming colon 45, just as represented or hinted in my string literal right here, or my string format over there. So guys, again, that is how we go about that. That is basically it about types. You can always read, and again, I'll share a book with us guys, where we can be able to read more about that, about the types. But for now, I hope you've got something. So what is a control structure? I've given that definition right here. So it's a way to specify flow of control in a program based on the analysis of a variable. So that is basically what a control structure means. And we have 3 types of control structures in any program. We have sequential flow, we have repetitive flow, so in this case what we refer to as loops. We have conditional flow, what you're going to talk about right now, the if statements. Now, if statements is a programming conditional logic that executes a block of code if the condition is met. So a block of code is only going to be executed based on some conditions that have been explicitly defined. At this point, we have if statements, we have if-else statements, we have if-else-if statements, and we have shorthand if. There's how it is represented in JavaScript. I just can't get the right name. Then we have match statements. So match statements are what in JavaScript we refer to as switch statements. So again, we're going to see how we go about that in right here. So let's get this started. So to declare an if statement, this is how we do it. So let's say we have we have a conditional expression right here going as follows. So if 56 is greater than 45, we want you to do what? To print that some statement right here. So we basically want you to print true. Very simple statement. Now, allow me to do some changes as well over here. So I'm going to execute some code from my conditionals file. So I'll just uncomment that within my mod.rs file. Then head back to my, I think I'm done with that. Then get back here. Yeah, so this is basically how we represent an if statement in Rust. So if I go ahead and run this, let's do cargo run. It prints true because 56 is actually greater than 45. So this statement got executed. Okay. What if we wanted to add an else block to our if statement? So again, I'll just build up on this. I'll just carry it down here. So this is where we're talking about the if else statements. Then assume I had an else statement right here. So, or an else block. I'll just flip my condition or the expression up here. So instead of 56 greater than 45, I have 45 greater than 56. So that statement is definitely going to be false because 45 is never or will never be greater than 56. So we don't expect this to be executed. Okay. Let me just have some different value here. Actually true. Okay. So we won't have actually true executed right there. We'll have the else block executed. So actually false executed. Okay. So the first true value is going to come from this, the first if statement. Then the second print value is going to come from the second if else block statement. Again, let's give this a try from our terminal. So our first true value came from the first if statement. Then the second actually false came from this second if else block. So the condition executed to a false value. And that's why this block was never executed, but the else block. I hope that is clear. Now I'll again just build up on that. Okay. Down here. And so this is the if else if block. So we're going to do if 45 is greater than 56, do actually true. So for us to, how do we represent if-else statements in Rust? So we have an if block. So before we have our else statement, we can do else if, then basically have another block right here, okay? So right here we can do 10 greater than 7. Then we basically have that block. Else, then we have an else statement right here. So this could be printing something different as well. Let's say this could print, let's just have it print else. For lack of some good statements to be printed. So right here, let me print 10 greater than 7. Then over here, print 45 greater than 56. Great. So at this point, 45 greater than 56 is false. So this block will not get executed. Else, if 10 is greater than 7, in which case this is going to be true. So this block is going to be executed. And immediately this is executed, we'll skip the else block and proceed with our statements afterwards. I hope you know that rule from your previous programming experience. Now, if I go ahead and give this a shot, you realize other than the two statements we have above right there, we are having 10 greater than 7 printed within our terminal. Why? Because the second else if block was true. If this were false, then it would basically execute the last statement within that if block, and that is the else block. Okay, so again, that is basically how we go about that. Let's talk about the shorthand if statement. How do we go, or what is this in the first place? Let's say you wanted to define or declare a variable, but then you wanted to do this based on some conditions, okay? So let's say we had a Boolean variable right here is admitted. No, let's say it's candidate. Is candidate, okay? So his candidate is going to be equal to a Boolean value, but then this Boolean value is going to come out, or because it's going to be assigned to this variable based on some conditions, okay? So if, let's give some simple expression right here. So if, and let's say we have this as your age. So say if 18 is, let me just have this defined right here. So let's say you have some age as 18. Then right here, I'm checking if age is greater than or equal to 18. If that is true, then you're actually a candidate. So that is true. Else, just do what? Return some false value. So we're going to have the is candidate variable hold these values based on these conditional, this particular expression or condition right here. So right here, we are assigning some value to this variable based on this condition. So if age is greater than or equal to 18, give it, if that is true, then basically assign true. If that is false, then just give it a false value. So something like that. So again, if I try to print this out, now, it's gonna give me, let's print out this candidate. And let's see what this is going to be from our terminal. So you realize that is candidate is giving us a true value, okay? So that is basically how we go about that. Now, right here, we also have a match statement. Think of a match statement as the switch statement in JavaScript, okay? So usually you have a value you want to test some cases against. So let's say you have the value 18. So if case 1 could be 17, you want to execute some information. If it is 15, you want to execute some information and all that. Now in Rust, that is available to us using the keyword match. So we can match the value of age that we've just defined somewhere here. Okay. Then we are saying, so we have that. So if age is 18, then we want to do some, this could be a block of code, in which case you're going to wrap it in curly brackets, or it could be a single statement or single line statement. In that case, you don't need to wrap it up in these curly brackets. Now, for us to be able to separate one case to the other, we use the comma. So let's say if the value is 20, we also wanted to do something here. Then we separate that with that comma. Then the default value, now usually in switch statements in JavaScript, the default value or the default block of code to be executed within that switch statement is usually indicated with the keyword default. Now in Rust, we indicate that using an underscore, just like that. Then giving it some statement. So let's say if none of the cases is met, then you simply want to print invalid age, something like that. However, if you're 20, you want to print of age, okay? And if you are 18, then you want to print, you're almost there, right? Then right here, we need to terminate this. So right here, I'm having a match statement that is going to execute based on the value of age. So apparently the value of age is 18. So we expect this to print almost there. I'll just give that a shot by running cargo run in my terminal. And you realize almost there is printed out. However, if I changed the value to 15 to 15, sorry, 20, so that we have these other case statement executed, that should now be able to print of age instead of almost there, okay? And that is exactly what has been printed in our terminal. So that, again, is basically how we go about that. If none of these was met, so say I had 15, then I expect my default statement or block of statement to be executed. In this case, it should print out invalid age. So again, I'll just give that a try. So let's say we do cargo run. It will basically print out invalid age, okay? So I really hope you guys have got that right. Allow me cover loops tomorrow in our tomorrow session.